Hello everyone, welcome to another tutorial on how you can build your own on-chain AI agents using ElizaOS and Gelato Relay on Ink. So we have developed this pretty cool POC and really excited to show you guys how this works. So let's get started. Hi everyone. So yeah, again, my name is Anirudh. I do developer relations here at Gelato, and in this video we'll cover what ElizaOS framework is, how what Gelato Web3 services are, what is CoinFlipAI. So that's like the POC, that's like the use case that we have built out. How CoinFlipAI makes use of ElizaOS framework with Gelato Relay Web3 services, and lastly, I'll demo to you guys live showcasing how CoinFlip AI works, and how you can play the game as well. After this video, I would highly recommend that you clone the repo, try playing the game yourself, and try betting on things. It's on testnet, so it should be pretty convenient for you guys. But yeah, really excited to see how this turns out for you. Right. So first of all, what exactly are AI agents? AI agents are self-operating, which means that they don't really need human intervention that much. They're able to perform these tasks, whatever they're given, like a specific task, they're able to do it without needing much human intervention. Secondly, they understand and respond to things. So once they receive their information, they'll be able to analyze that information in their environment. They'll be able to make decision based on that, and they'll be able to take action to achieve their goals. And lastly, they just keep learning and improving. So the more the tasks that they do, the better it improves over time. So that's like one of the core responsibilities of AI agents. So that's what exactly an AI agent is, to sum it up. And what exactly is ElizaOS? ElizaOS is the operating system for AI agents. It's an multi-agent simulation framework for autonomous AI agents. So basically what this means is that you can build and you can deploy agents using this framework. And you can design custom AI personalities with memory and decision making as well. A bit of context about this project is that it's developed by AI16Z. It's an AI-driven DAO. Yeah, it's AI16Z and A16Z are not officially affiliated. And this project is open source, so which means that you can go ahead and read its code. You can perhaps go ahead and make some pull requests as well. Yeah, that's the link, github.com/ElizaOS/Eliza. So yeah, feel free to check out the code. It's in TypeScript, which means that it makes it super easy for all these TypeScript based SDKs to just go ahead and integrate the SDKs into the plugin, so the Eliza OS, the agents can interact with your framework easily. Right. Now let's dive into Gelato Web3 services, starting off with Gelato Relay. Just gonna give you a top level overview. Gelato Relay is the most trusted and the efficient solution for gasless transactions. It enables gasless transactions, supports ERC20 as payment token, and it scales relayers with increasing transaction volume, and it's available on 30 plus networks, including Ink and Inksepolia. How Relay actually works is that you determine gas sponsorship approach first. So you can either choose on-chain payment where the users pay gas with native or ERC20 token. And then lastly, you have this off-chain payments where you sponsor partial or full users gas with one balance, which is a gas tank which allows you to pay for transactions on all the supported networks on Gelato. Then there are four SDK methods that you can use. One is the on-chain payment, which you can call with sync fee ERC2771, and then you have call with sync fee. Then you have the off-chain payment, which you can use sponsored call ERC2771 and sponsored call. And then lastly, all you do is you just deploy or upgrade your contract, you integrate the SDK, and you just launch. And this will allow you to pretty much relay the transactions from your UI or from your backend to your smart contracts gaslessly. And that's like the advantage of Gelato Relay. So functions, these are the Web3 leading smart contract automation solution. And basically, they allow you to react to on and off-chain events. also access any off-chain data, computation, or APIs. They also provide you with advanced monitoring. And lastly, they're available on 30 plus networks and on Inxapolia. And how this essentially works is that you select your trigger. This could be time interval or cron, this could be block, or this could be an on-chain event. And based on this trigger, you can define what to run. This could be a TypeScript function or a Solidity function or a transaction, which could mean like a simple transaction. And basically, all you do is top up your one balance with USDC. Like I mentioned, it's a gas tank which will sponsor and pay for transactions uh, for all the supported networks that Gelato supports. And basically, your task is up and running, and this task will automate based on the conditions that you have set on your task. So that's functions. Lastly, we have VRF, which is the cost-effective and on-demand verifiable randomness. And how this works is that it's verifiable, it's unpredictable, and unbiased random number. It's also compatible with Chainlink VRF. It's saving 16% on costs. Its advanced cryptographic technique prevent manipulation. And again, it's available on 30 plus networks, including Gelato rollups. And this means Ink and Inksapolia. So how you implement VRF is essentially you just implement your contract, you inherit the Gelato VRF consumer base, and you just pretty much you know deploy your contract. Then you go over to the Gelato UI, you top up your one balance, head over to Gelato VRF, and add the contract address in the Gelato VRF app, and then basically you launch the task, and every time the request randomness event is emitted from your contract, the Gelato VRF task will essentially fulfill the randomness in your contract. Uh, y- so that's how VRF actually works. Right. So now you have the context about all the Web3 services. I would like you to understand what plugin Gelato is. So basically, plugin Gelato is an plugin which is now integrated in the ElizaOS repo. And what this does is that it will allow you to relay transactions using your AI agent. And basically, you'll be able to relay transactions using sponsored call and sponsored call 2771, uh, given the correct prompt and all the necessary details, and how you implement the plugin yourself on top of this plugin, right? And this makes it easy for you to interact with the network using a ChatGPT-like interface. And you can check out the official plugin in this link over here. Cool. So now let's dive into CoinFlip AI and what CoinFlip AI actually is. So CoinFlip AI is an automated and AI-driven betting game where players place bets and an AI decides the winner through the fair for coin flip. And the game is fully decentralized with on-chain transactions and Web3 automation, ensuring transparency and trust. So let's see how does this actually work. So what happens is that firstly, players they will spin up the AI agent locally on their computer. So players join and place bets, and that's how they join by spinning up the server locally and connecting to Inksapolia to the contract itself. And then player interact with the AI assistant in the chat, and the AI helps them place their bet using Gelato Relay, and game waits for the next round. So every minute a round is concluded. So the game runs is fixed in intervals. So every 1 minute, and this is coordinated by Gelato Web3 functions. And all bets placed before the timer runs out are included in that round. And then what happens is that the Gelato VRF flips the coin every round. And once the timer reaches zero, the round is locked. And Gelato VRF generates a truly random coin flip, and the results can be verified on chain. And then the winners are decided and announced. So the game instantly finalizes the result. And then every minute, let's say the player can ask who won or did I win to get the results of the game, right? So this is how this works. Let's take a look into the diagram of how this works. So, like I mentioned, you have the set of players that spin up the agent locally with the chat UI. So player one, player two, player N. There could be as many players as you want. This game is multiplayer. So players run this locally on their game, locally on their computer, and they send out prompts about placing their bets, which is then relayed through Gelato Relay, which helps them place the bet to the smart contract, which is deployed on Inksapolia. And then what happens is that we have a Web3 function which runs every minute, and this is queuing for all the bets placed in the last 1 minute. And basically, what happens is that once every minute, this will call for request randomness for round, which means that the round is concluded automatically. And what happens is that you have Gelato VRF listening for this request randomness event, and it will then deliver uh, the fulfill randomness, which will then essentially conclude the coin flip and declare the winners in the smart contract. And then we also do have a backend server which keeps track of everything, just so it makes it easier for the players to for the agents to actually query data. So that's why there's a backend server. So that's like the gist of how this works. And yeah, that's how this POC has been implemented. Just a few screenshots, just so you have some idea about how you can play the game. So you can ask like, hey, can you explain me about yourself and what you do? So yeah, the coin flip, uh, the flip master will be like, hi, I'm the flip master, your dedicated AI assistant for the coin flip betting game, and I can help you place bets, etc. So it's just like a chat GPT interface, but you can play game with it on chain on Inksapolia. So over here, as you can see that I've written place a bet for me with 0.01 ETH. And then this will then go ahead and place a bet for me. And it also provides me with all the details about the relay transaction, which I can track as well. And then every minute, let's say once the round has been concluded, I can ask, hey, did I win? And then as you can see, I lost in this round. So yeah, this is how I can query that if I won or lost. And yeah, so that's like what CoinFlip AI is. It's time to get into the demo. Before we get into the demo, there are a few prerequisites for this in order for you to spin this up locally. So you have to ensure that you have node version 23.3.0, you have PNPM, and you have the .env from the repo, which I'll show you shortly, and you have the env file set with the wallet key, the Gelato Relay API key, and something that's optional is that you can also have the OpenAI API key to make it easier for your AI agent to use a specific model from OpenAI, for example. But this could be something else. This could also be like DeepSeek. This could be Grok. Could be anything that you prefer. I just went ahead with OpenAI for just for the simplicity. Right. So let's dive right into the demo right now. All right, let's get started with the demo. So yeah, it's pretty straightforward. We have this repo. It's going to be down in the description below as well. So head over to this link and check out to update Gelato plugin. That's like the main branch that we're going to be using because this is where the code for the agent is implemented. So yeah, it's just a fork and I've built on top of the fork of the official Eliza OS repo. So yeah, feel free to clone this, and yeah, just have it cloned it locally in your local machine. I've already done that, so I can show it to you. So yeah, this is how it should look like when you clone it locally. I have this Eliza conflict player too, and when you start the yeah when you open up this repo, you should be able to see the code for the game itself in the folder called plugin gelato, and it's all in action user friendly, right? So everything over here you should be able to see like all the logic about the game itself, right? So this is where the logic of the agent has been implemented. Feel free to take a look and play around with it. But yeah. So cool. Let's try to build this project. I'm just gonna spin up a new terminal and I'm gonna write you know, I need to ensure that I'm in update Gelato plugin. I've already done that, so make sure that you're in update Gelato plugin branch. And then I'm just gonna write pnpm run build. Then this is gonna build it for me. This might take a little longer if you're running it for the first time, but yeah. And then secondly, I'll have to run pnpm install to install all the packages. I see one error that my node is not 23.0.0. Let me just check that. So one of the prerequisites of this project is that your node version should be 23.3.0. So I'm just going to change it. So it's going to be nvm use 23.3.0. And then I'm going to run the pnpm install again, just for being a little safe. Cool. And then now I'll cd into agent, and then I'll run pnpm install again. Nice. Now I'm just gonna run pnpm run start to start the server of the agent. Cool. So everything is now spin up. Everything is now ready. I think I forgot to mention one thing is that before we get started, we need to ensure that in your env.example, you need to ensure that you first of all have the EVM underscore private key, which is going to be your wallet private key, and the provider URL. So in this case, it's going to be the provider URL of Inksepolia. To be honest, you don't really need this because there's already a public RPC for Inksepolia also being used in the agent itself. However, if you would like to use a private RPC just for the sake of better connection, feel free to use one over here. And then nextly, you'll be needing the Gelato Relay API key to sponsor your transactions from this agent to the target contract. In this case, is going to be the CoinFlip VRF contract on Inksepolia. We'll be going over the contract as well shortly. And I think well, as an optional, I'm using the OpenAI underscore API as well. I would like to use a GPT-4o model because it's just make it simple for me. I don't have to run the model locally, but you can run the model locally as well. You can use, Llama. You can use any other provider of your choice. I just decided to go with OpenAI, but feel free to use any of your choice. So yeah, so that's done. Now we have the backend server running of the agent on our machine locally. Then I'm going to start the UI. So I'm just going to run pnpm start client. Yep. I think now our UI is being run on 5174. We can confirm that by going over here. So I'm currently running two instances of two players just for the sake of demo, but yeah, ideally you can just use one. So yeah, it's just to showcase that multiple players can play the same game. So I'm spinning up two players with two different wallet addresses just for the sake of demo, right? So we have two players, player one, player two. And basically I can and this is how you set up the environment in order for you to play the game, right? So that's step number one. Step number two, let's go over the contract for the game real quick. So before you start playing the game, you need to ensure that you have deposited into the contract. I've currently deposited like 0.414 ETH. That's like my current balance. So that I can play with this amount of money. So I can bet, how much ever I want from this. And there is a minimum bet amount as well, which is 0.01 ETH. So yeah, that's part of the game. And basically, once you have ensured that you've deposited into the contract, it's just as simple as going into. So basically, first you need to ensure that you have set up the development environment properly. And step number two would be to ensure that you have deposited enough funds in order for you to play the game. So the minimum bet is 0.01 each. So you need to have completed both of these steps in order for you to now start playing the game, right? Next, it would be just as simple as talking with the UI and just playing the game. So yeah, let's talk to the UI right now. I can just ask it. So, can you tell me about yourself? Right? And then it should tell me like, yeah, I'm a flip master. I should be able to place bets for you, etc., etc., right? Let's look at the response. Cool. That's pretty sick. Yeah, it will help me place bets, all right? I can also say how do I play this game, right? It should provide me with some instructions, some basic instructions. Like, yeah, I can type place bets, right? So that's part of it. Perfect. So yeah, feel free to any. All right. So I'm just gonna place bets now. So yeah, I have two players, player one and player two. And in both the cases, on one player I'm gonna write heads. I'm gonna bet with heads, and in one player I'm gonna bet with tails. So yeah, place a bet with 0.01 ETH on heads, right? And then over here I'm just gonna write place a bet with 0.01 ETH on tails. Right, so let's do that. This is player two. This is player one. And let's see, compare them side by side. All right, so we have bet placed. We have bet placed on both of them. Let's check out this relay transaction. So now we have this Web3 function running, which will pick up all the bets placed in this round. Right, let's look at the logs. So it's just executed 40. It should be able to find two bits. We can see it on the logs over here. Here we have bet place and we have bet place. So we have two bet place events. Let's look. Yep, found two bet placed. Let me just zoom it in for you. And as you can see that both of these have been uh, both of these have been detected. And now this round is over. So we have now just concluded round number four. And we can see that the randomness was emitted from Gelato VRF at 1941. So as you can see, this round was emitted, and Gelato VRF actually called to, resolve the round. And then maybe we can check if the round was actually resolved using the contract over here. Right, we can see round has been resolved, right? And we can actually see that the winner is 0x0p. So if I head back over to this one, I can say, hey, did I win? Did I win, right? Just like a simple prompt. And ideally, I think this is the player that won the game. Similar for this, like did I win? Right? Did I win? Let's check out the results. So yeah, this player won because I bet for tails, and let's check out this one. So yeah, this one lost, and the other player won. So yeah, this is a multiplayer game. It's pretty interesting to see how this works. It makes use of relay, Web3 functions, and BRF, everything combined together. So it's like a pretty interesting use case. Please feel free to spin this off yourself and try playing this. Would be really interesting to see how this turns out and what your experience is like. So yeah, thank you so much. And yeah, let me know if you have any questions. Happy to help and see you later. Bye.